It is time for some binomial expansion using Pascal's triangle. I'm sure you've heard about this triangle before. It's pretty incredible. All right, so let's take a look here. If we start expanding on our own, if we had x plus y to the 0 power would just be 1. Anything to the 0 power is 1. X plus y to the first would just be x plus y. Now, if we have x plus y to the second, don't forget you need to FOIL this, right? Don't make me upset and just like distribute your exponent. That's incredibly wrong. You'd have x squared plus 2xy plus y squared, okay? Because I'd have xy and xy gives me 2xy. Next one. Well, I know that these two together are what we had prior. So I'd really have x plus y times x squared plus 2xy plus y squared. So let's continue by distributing, right? I need a little more room here. I'll pop up here. There we go. So I'm going to have x cubed plus 2x squared y plus y, or x y squared. And now I'll distribute the y. So plus x squared y plus 2xy squared plus y cubed. So let's see if we got some like terms here. We've got those two. So I'm going to have x cubed plus 3x squared y. And then I have xy squared, those two. So plus 3 xy squared plus y cubed. Okay. Cool. Now, if we were to continue on, that looks terrible, okay? I don't want to keep doing this. Perhaps there's a better way. If you look where we are right here, the last one we just did, look at those coefficients. We have 1, 3, 3, and 1. Same with what we see there in this expansion here, and then we can keep going here. There's a pattern. Then it's 1, 4, 6, 4, 1. And if you look at the exponents, well, if we go to our previous one, the one we just expanded, it starts with cubed. Actually, let me get them both in frame here. Okay, I get my first guy cubed, then it's squared to the first, and then to the 0. And up here, cubed, squared to the first, and then there's no x there. It's x to the 0. Okay, so we have this wonderful pattern here that we're going to be working with here today. That'll help us out, save us a little bit of time. Time is money. That ain't funny. So this we have right here is Pascal's triangle. And it can be expanded indefinitely, okay? But we've got the basic gist of it. And let's look for some patterns here so we're not just trying to memorize these numbers. So if I've got the first two here, take a look at, and let me use a marker here because I think my cursor doesn't always show up very well. 1 plus 1 gives me 2, right? And then 1 plus 2 gives me 3. 2 plus 1 gives me 3. And then 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. So on and so forth. Okay, so we see how that like trickles down. All right, that's how this triangle is formed. So you don't have to necessarily memorize the entire thing. You could form it if you want. Okay, it can be helpful to know the first few lines, but you can go ahead and make it yourself if you've forgotten the numbers. Okay. Cool. You can also notice that the exponent here matches up. 3, the first guy. 4, the first one there. 5, the first one there. Okay. And then also notice something that we have one more term than the exponent. So if it's raised to the 5th power, I'm actually going to have 6 terms. If it's raised to the 4th power, I'm going to have 5 terms. These are all things that you might observe that, yes, that is the case. Okay, sometimes we're like, hey, is that a pattern? Is that a thing? Or is it not? Yes. Okay, a lot of patterns, a lot of awesomeness. How about we get to expanding? Let's do that. Let's work this first one here together. Okay, so I have to the 4th. I'm using this one. Okay, so to start, I would have 1, and then it'd be x to the 4th. Cool, first term done. My second term is going to have a coefficient of 4. And then the x will be to the third power times 3 to the first. And we're going to have to do some simplifications here in a sec. Then, coefficient of 6, I'll have the x squared. And then my second one will also be squared, so it'll be 3 squared. Notice how my first term's exponent is decreasing by 1. The second term is increasing by 1, starting with 0. The next move, 4, and then I'd have x to the first, and then I'd have 3 cubed. And then lastly, x to the 0, and then we'd have 3 to the fourth. So now let's simplify. Shall we? All right, so we've got x to the fourth plus, and then it's 4 times 3 is 12x cubed plus, and then I have 3 squared is 9 times 6 is 54x squared plus, and then 3 cubed is 27. 27 times 4, that's 54, 108. And then 3 to the fourth is 81. X to the 0 is just 1, so it's just 81. All right, and once again, I like to observe this again. I got 4, then 3, then 2, then 1, then nothing. The darn bell. And then obviously, since my second term was a constant, it was 3. That's not a variable. You're not going to see that anymore. But we saw that in the initial, how it went from nothing. We could even have shown a 3 to the 0 power here. And then 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. That's a lot better than multiplying 2 binomials. Then multiplying that binomial into the trinomial. Then multiplying that binomial. Oh my. Terrible. All right, let's try a couple more. All right, next one here. So we've got, if you didn't forget, or if you didn't remember, excuse me, it is 1, 5, 10, 10, 5, 1. All right, so what I'm going to encourage you to do is pause the video, try expanding it, hit play when you're ready, and the work will pop up. Did you pause it? Didn't think so. Pause it. And there we have it, folks. Now, I know it looks a little weird with like the 280s there, just how the numbers worked out, right? Yeah, there we go. Awesome. Next one. Ooh, little curveball here. We got a 3y. Okay, so now not only do we have a coefficient with that variable, right? So let's try expanding that one. See what you can do. Hit pause and then play whenever you're ready, and you'll see some of the work pop up. All right, so here's the initial work. We've got a negative in here as well, which I forgot to mention, but hopefully you're like, ooh, that's a twist there. It's a plot twist. So we're going to see some alternating signs here once we evaluate this, because raising a negative to an odd power will retain its sign. Raising it to an even power will change it to a positive, right? All right, let's get some simplifications going. So we'd have 3 to the fourth is going to be 81, y to the fourth. The negative 2 to the 0 is just 1, so that's that for that one. Then I have 3 to the third is 27 times 4 is going to give me 108 multiplied by a negative 2, because negative 2 to the first is negative 2. That will be negative 216. So minus 216. Oops, I lost my y there. Y to the third. Next one. So I've got... let's see here. We got 3 squared. Sorry. 3 squared is 9. Negative 2 squared is 4. That's 36. All right? And then 36 times 6 would give me positive 216. Y squared. Now this next one, if we notice the pattern, this should be a negative, right? Because it's negative 2 cubed, which is negative 8. 3 to the first, that's just 3. And then 4. So I have 4 times 3 is 12 times negative 8 is going to give me negative 96. Yeah, 96. There we go. 12, 8 feet, 96 inches. That's how I remember it. Lovely. Y to the first, so just y. And then last one, 3y to the 0 is just 1, right? So it's gone. Negative 2 to the fourth is positive 16. Okay. There we go. Beautiful. Box it. Awesome sauce. Ooh. What do we have here? Expansion of a complex number. Well, let's see here. If we were to expand this, one, I do like writing down my the line of the Pascal's triangle, right? So 1, 3, 3, 1. So let's go ahead and expand this just like we've been doing. So I'd have 1 times, then it would be 5 to the third, and then negative 5i to the 0, plus, and then we'd have 3, and then we'd have 5 to the second. And there we go. Now it's time to simplify, right? So negative 5i to the 0, that's just going to be 1, so I'll get 125 plus, and now what do we have here? We've got 25, 5 squared is 25, times 3 is 75, okay? So 75 times negative 5, right? Because negative 5 to the first is negative 5. Would give me negative 375. And then I have I to the first, so just I. The next one, negative 5 squared is 25. 5 times 5 is 125. Times 3 is 375. But this guy right here, and I'll do this in a different color just so we can see it. 375i squared is going to give me negative 375, right? I squared is negative 1. Okay. And the last one we're going to have would be, let's see here, negative 5 cubed is negative 125. I to the third. So I think we want to do another, sorry for the pause there. Let's evaluate this one all together here. We're going to have negative 125 I to the third, just so we're not doing too much in our heads. That would be, that's like I squared times I. So negative 1 times negative 125 would end up being positive 125 and then an I, right? Let me backtrack that for you guys just in case you're like, wait, what? 125, and we have I squared times I if we want to break it apart that way. So that would become positive 125 because I squared is negative 1 times I. So plus 125 I. Now I can combine some things, right? So I'm going to have looks like negative 250 minus 250i. Okay. So that's one way of doing this, right? And as we know, there's many ways of doing various math problems. Perhaps we can do a little throwback to Moff's theorem, right? Let's see if it works out the same way de Moff would do it, you know? Okay, so let's draw it up. So I'd have, what quadrant would we be in? To the right 5, oh, down, fourth quadrant. So I'd have 5 here, negative 5i here. This would be 5 square root 2. Cool. So I'd have 5 root 2 cis, and then it would be negative 45 or 315. I'll go negative 45. Keep the number smaller that way, right? To the third. Now, if you remember, we are going to raise this part, the coefficient. That's going to be raised to the third. So I'd have 5 to the third is 125. And then root 2 to the third would be 2 root 2. So I'd get 250 root 2. And how do we get root 2 there? If I were to cube 2, that'd be 8. So square root of 8 simplified down to 2 root 2. That'll work. Okay, and then I have cis. Hold on now. Negative 45 multiplied by 3 is negative 135. All right, so now I'm going to break this apart like this. 250 root 2 cosine negative 135 plus 250 root 2 sine negative 135 I. So negative 135, that's in the third quadrant. Both cosine and sine are negative there. So I would have 250 root 2 times negative root 2 over 2 plus 250 root 2 times negative root 2 over 2 I. Let's see here. The root 2's multiply to become 2, which then cancels out with the 2 in the denominator. So I'm left with 250 plus, and then, ooh, that's a negative though. Oh my goodness, the bells. Minus 250 I. So these, just to point out what I was talking about here, this becomes 2, which cancels with this. This becomes 2, which cancels with that. Cool. All right. So another way to do that problem. It's kind of neat, seeing it done in different ways. I find that to be quite fascinating. But then again, I'm a math teacher, so I find math things to be quite fascinating. All right. Awesome. All right. So for this one here, Pascal's triangle, fun. Okay. So this is going to be fun. Tell you what. Let's complete some more rows of Pascal's triangle, shall we? So we'd have 3 and 1, right? 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15. Remember, I'm just adding the two above together to get this one, right? 1, 7, 21, 35, 35, 21, 7, 1. Okay, now we can keep going here. I'm going to pump the brakes because that's a lot of writing. So find the sum of each row by adding across the rows. What pattern do you see? Well, the first one's 1, the second one's 2, then it's 4, then it's 6, 7, 8. Then I have 10, 15, 16. And then I have 20, 32. Okay, this is interesting. I'm starting to see something. And then we've got 20 plus 30 is 50, 62, 63, 64. I'll be willing to bet you this is going to be 128 right here. And then I bet you it's going to be even bigger than that. Right? Guess I'm what, 256? Okay. Well, what's happening here? Can we find a pattern? Let's see. I'll go with, that's fun. This is an aha moment. This would be 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth. Oh my goodness. 2 to the fifth, 2 to the sixth, 2 to the seventh, 2 to the eighth. Ah! Oh, okay. Okay, so we got something going here. Cool. So the pattern we see here is if we start with 1 for our first, then it's multiplied by 2 to the n. Right? Cool. So find the sum of the 20th row. And again, n would be our row number, starting with row 0, right? Not row 1, starting with row 0. Find the sum of the 20th row. Well, I would just have 1 times 2 to the 20th. And that would be, whatever. We'll just leave it as 2 to the 20th. It's going to be a big, you know what? I'm strapped. 2 to the 20th. Woo. $1,048,576. That's a lot. Okay. So now we want to write the pattern as a geometric sequence for the sum of the nth row. Okay, so we could do the 1, and I'll change markers here. It's not the same. 1 times 2 to the n. Or if you wanted to keep with the, the n minus 1, we could do 2 to the first times 2 to the n minus 1. That'll work. So either one of those is Gucci. Find the sum of the first 100 rows. Okay. So let's see here. I'm going to go with my my formula here. Let's say we got the sum of the first 100. Well, my first term is 1. 1 minus 2 to the 100th. Since our rows start with 0, right? Over 1 minus 2. And that is a hefty number. It's calculator time. Let's see here. I'd have 1.2676 506 times 10 to the 30th. That's like unfathomably large, right? Like I don't even have context for that. That's just a huge number. It's huge. All right. Ooh, find Fibonacci's sequence in Pascal's triangle. It's like they were buddies. All right, so this is a little tough to see. Kind of like me right now. My camera went out. I don't know why, but we're just going to finish this thing up. Yeah. So to find Fibonacci's sequence, it's actually a little bit weird. So bear with me. Uh-oh. Okay, we're starting to have some technical difficulties here. Let's see. So if I were to draw a line, oops, like this, okay, and then another one and add that, that'd be 1, okay, and then, so hold on tight here, 1, and then if I were to draw another diagonal going through 1 and 1, but nothing else, that would give me 2, and then between, I'll get the 2 and the 1, that gives me 3, and then 1, 3, and 1, that gives me 5. And then, let me just erase some of this. And then let's see here. We've got 3 plus 4 is 7, plus 1 is 8. And then if I go through, I got 1, 6, that's 7, plus 5 is 12, plus 1 is 13. And notice I am adding the previous, just like our sequence there, our Fibonacci sequence. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 3 plus 2 gives me 5, so on and so forth. And I can keep on going on this. 4 plus 10 is 14, plus 6 is 20, plus 1 is 21. And that would be the addition of the previous two terms. We can do that all day. But we'll stop there because we're out of numbers, obviously, in what we have done so far. And that's that. Okay, so a lot of cool stuff with Pascal's triangle. You can actually look for other patterns there. You would even look them up on the Google machine to see if there are any other patterns with Pascal's triangle that you may not be able to see. Maybe we can talk about them in class because that's awesome. All right. Sorry my camera went out. At least it was at the very end of the video. Hope you guys have a wonderful day. America, freedom, rock and roll, Costco, YORO, hashtag YORO, you only round once. And, of course, Riverdog Jenny on the ground. See ya.